AutoFrame, the biggest time saver in Premiere, Mytech's leading whole house engineering software. With one click, AutoFraming creates all the framing zones for you so you do not have to manually frame. Today, I'll show you how to refine those macros so your final design is tailored to your exact needs. Cut out the setup time so you can dive straight into the detail that matters. We all know how great the AutoFraming tool can be. Simply put in your wall and surface geometry in, click AutoFrame, and Premiere does a great job of framing your design. And it works time and time again with those everyday jobs. But how well does it hold up when we move into more complex geometry? So here we have something a bit more challenging. We have a design with lots of intricate features, some large hip sections, got a dog leg section there, circular roof section, raised ceiling levels, and a lot more interesting areas. You could approach this the manual way, adding in a girder arrangement, and then manually framing out your sections. It's effective, but it's time consuming. With a complex design, this is where time can really disappear if you're building everything manually. So before we reach for those manual tools, let's put AutoFrame to the test and see how it handles this complicated layout. Okay, it's done a great job and it's put framing zones in each of these sections. And now we've got those framing zones in place, we can alter and tweak them to give us the design that we want. So let's start with the louvered hip section down at the bottom. Okay, so we've got this floating canopy corner, which is going to need some support, and we can just simply add another framing zone on top for this. So by selecting manual framing zone and selecting canopy base from the drop down, and then I can just place it in the area that I need it. Okay, if I select the macro, we can configure lots of different settings here. We can alter the lapping detail of the beams, we can change the extension of the beams, the material, and other features as well. By having that macro in place, it allows us to easily and quickly configure the frames as opposed to doing it all manually. If we go further up, we have this roof run, and we can see the end truss is stopping a little short. This is because we have some interaction with that end girder. So to fix this, it's super simple. We can simply reverse the direction to stop that interaction. And then if we reverse it back, we can see that truss corrects itself. Let's move over to the flying rafter hip section. Here we have the hip board stopping a little short from the wall. Okay, we can correct this within the framing zone macro by changing the main truss reference from back edge to front edge, which moves that truss outside of the hip area and corrects that hip board position. And we can clean this up further by trimming the girder to the inside of the wall. And we can move that last truss 50 millimeters away from the wall. Great. So let's move over to the top of the building and look at this hip section. Currently, we have a two-stage hip in place, which is a sensible choice for a hip of this size with two girders. But we can try and change this over to a standard flying rafter hip, so we only have the one girder. And we now have some more options on how far back we can set that girder. Moving the girder back is going to increase the truss height, which is really useful because a shallow girder behaves more like a beam and it may require extra plies. Increasing the setback gives us the extra height needed to potentially avoid that. Now, my preferred method to achieve this is by decreasing the number of hip trusses, which is really simple within the macro by setting the placement to number of hip trusses and just reducing that quantity down, which brings that girder back. Now, the downside to moving the girder back, it results in a longer supported span for that hip board. That longer span can increase the timber size needed for that hip board. So what we can do to fix this, well, we can set the corner to be girder based, which introduces another set of trusses in the corner. Now we have extra support for that hip board as it's carried by both the hip truss and the mono truss. We can also move that mono hip girder further down within the macro by increasing the number of hip trusses. This evens out the support distances and should result in a more reasonable timber size for the hip board. So, if we move over to the valley section just below, so with this valley section, we have a higher tier. So the incoming roof is higher than the main roof, which hasn't quite put in those flat valley frames we'd expect. Now this is a super simple one to manually frame, so we can simply just copy perpendicular on one of those valleys, and the shape of the frame will take the geometry of the surfaces for you, as we can see there. Perfect. Okay, if I bring us over to this poly hip section, everything's looking pretty good. However, the main girder is poking through the roof surface slightly. And you can see that in 3D better, where it just protrudes through the surface slightly. But the framing macros make it really easy to fix this issue. We can simply just change the girder reference from center total to front edge, which pulls that girder back nicely. Great. So let's go over to the other side of the building. We have an area where the firewalls are raised all the way up to the roof surface, so the auto frame doesn't populate this area with frames. We can easily apply a framing zone roof run to this area by simply going to the manual framing zone, roof run, and we can also select single surface, and it puts the frames in as we expect. Easy. And then finally, just above that, we've got this dogleg section. Now, the first thing we need to do here is build the supporting girders for the macro to determine the framing arrangement. If we look at the profile of the supporting girders, we have two think trusses. If we were to change the web pattern of these to include verticals, and also change the macro back to dogleg corner macro, we now get a design which includes perfectly aligned purlins within the verticals of the supporting girders. The framing zones are intelligent enough to pick up the geometry of the girders and adjust the frames accordingly, which is a massive time saver. And there we have it. Auto framing and framing zones are the smartest and quickest way to frame a building. Get the macros to do the heavy lifting and cut out the manual work. So the next time you're looking to frame your model, save yourself some time and put your trust in auto frame and those framing zones. If you want to learn more about MyTech Premier, the leading whole house engineering software, like and subscribe.